All right, good day, everybody. Here I am, and I would like to go over some additional examples, more commensurate with your homework, and hopefully a big help. So, let's start with, let me get my board situated here. We're going to start off with a motion problem where we're talking about the river and the special rate that we give motion problems. That had to do with when you're going upstream and downstream. So basically, when we're looking at motion where we're going uphill or downhill or with the wind, against the wind, then I want my formula to be distance equals the rate. But the rate now is going to be x plus y. And another equation is going to be where the distance equals x minus y. And that's just for the rate. And then you will multiply that by the time on the right side. Okay, with this now, a couple things we got to remember is the x is referring to the still water and the y is referring to the current. All right, and t, of course, is time. So we got a couple special things going on here. So let's see. The current of a river is 2 miles per hour. All right, so what I'm going to do right here, I'm going to replace the y's with the 2. So let's do that right now. Get rid of the y's, and let's replace them with 2's. Okay, a boat travels to a point 8 miles upstream and back again in 3 hours. So our distance is going to be 8 hours for both of these situations, going upstream and downstream. So let's give that an 8 for each equation. And then it says to us that going there and back takes a total of 3 hours. So at some point in this equation, when we're figuring this out, we're going to get these to add up to equal 3. All right, because we're talking about going upstream and downstream in the total of 3 hours. Okay, it's not separated. Okay, so what now is crucial to do here is I'm going to get rid of this r so we're not confused by anything. I want to get these equations equal to t. I'm going to solve for t. And when I do that, I'm going to divide both sides by x plus 2. Okay, what do I have? The x plus 2's cancel. The t is by itself, and it's going to equal 8 over x plus 2. All right, there's one side. That may be going downstream because of the x plus 2. This is going upstream, and I'm going to divide this side by x minus 2. So t over here is going to equal 8 over x minus 2. Okay, given that, if I have t equals this and t equals this, then I'm going to replace this t here with the value of t on the right side, 8 over x minus 2. 8 over x minus 2. Okay, this is what I've got. And now I'm at the point I got them equal to each other, but now I want to add these two together so it equals 3. Let's try that. All right, so here's where we're at this point in the problem. And let's get our denominators to be the same, shall we? This is really over 1. This 3 is over 1. Make sure we remember that's a 3. All right, so this x plus 2, I'm going to multiply by x minus 2, top and bottom. The x minus 2, I'm going to multiply top and bottom by x plus 2. And bottom, x plus 2. And the 1, I'm going to multiply by x plus 2 times x minus 2. And again, that's top and bottom. And we know why. We're getting our denominators to be the same. That way we can ignore the denominators and solve for the numerator. All right, so let's see what we've got here. I'm going to distribute the 8 times x minus 2, and that's going to give me 8x minus 16 plus 8x plus 16, and that's going to equal this right side, where I've got 3. Let's see, if I multiply x plus 2 times x minus 2, that's going to be x squared minus 2x plus 2x minus 4. I got a negative 2x plus a 2x, so those cancel out, and I'm just left with 3 times x squared minus 4. These are gone now, right? I just got x squared minus 4. And then let's distribute that. That'll give me 3 times x squared is 3x squared minus 12. Okay, let's see if we can hang on to that. All right, we can. So let's solve. Notice I'm going to have a quadratic here. So I'm going to bring the left side over to the right side. That way this can stay as positive 3. So I've got, well, here I got a minus 16 and a plus 16, so those cancel out. And 8 and 8 is 16x. And that's going to equal the 3x squared minus 12. And I just have to subtract 16x to get the equation equal to 0. I'll do it like so. So I've got that 0 equals what? 3x squared minus 16x minus 12. And that's my problem now. I'm solving for x. And boy, that would go away. All right, so I can't get rid of the 3, so I got to do the grouping method. 3 times negative 12 is negative 36. I want 2 values of factors that will give me negative 36 and add up to be negative 16. So it must be 18 times 2, with the 18 being negative. All right, let's rewrite the problem. How about 3x squared minus 18x plus 2x minus 12. And we know it's equal to 0. Let's do a little grouping here. And when we do, I'm going to factor out the left binomial by taking out a 3x. And what's left over is x minus 6. Bring down my plus sign. The right binomial, I can take out a 2. And what's left is x minus 6. Always the same thing as the first one. Equal to 0, of course. And then I'm going to take out the common binomial factor of x minus 6. And I'll say what's left over? Equal to 0. Now I got to make this statement true. So x has to equal 6, or x has to equal. Now when you get these with the coefficient with the x, you can bring it over to the side here, 3x plus 2, and get it equal to 0 and solve for x. Okay, so I'm going to subtract 2 on both sides. 3x equals negative 2 and divide by 3. So this is giving me that x equals negative 2 over 3. So what are we solving for here? It can't be negative. What is the problem? What is the speed of the boat in still water? So we cannot have speed be negative. So this is not an answer. So I discard that and I go with this answer of x equals 6. That's the speed of the boat in still water. All right, so there's the first one. I think I've got 4 or 5 in total. Wanted to let you get some extra lessons about it, these story problems. So let's move on. Here we go. With a small airplane flies 810 miles from Los Angeles to Portland, Oregon, with an average speed of 270 miles per hour. An hour and a half after the plane leaves, a Boeing 747 leaves for Los Angeles for Portland. Both planes arrive in Portland at the same time. What was the average speed of the 747? All right, let's do our setup here. And how about we've got, I always do this. Just have it, distance equals rate times time. Just kind of helps me get things right in my head. And we have two of them normally. Times rate times time. All right, again, this is a problem that does not involve motion where you're going against the wind or with the wind or uphill or downhill, anything like that. All right, so we're going to have a small plane flies 810 miles. All right, so here's a small plane on the left side. It's going to go 810 miles at a rate of 270. So they're just giving us the rate. They're giving it flat out, the rate, and that's going to be multiplied times the time. Okay, I'll do it like that. I like to put things in parentheses to signify that we're multiplying those two. Okay, an hour and a half after the plane leaves, a Boeing 747 leaves Los Angeles for Portland. Both planes arrive in Portland at the same time. What was the average speed of the 747? Okay, so I've got a problem with an hour and a half after the plane leaves. But let's see, how about getting this distance? The distance is the same, so it's 810, and that's going to be, we don't know what the rate is, and what do we know about the time? I'll put it here right now, just as the time without talking about an hour and a half after the plane leaves. Okay, I won't do that right now. All right, so now what we want to do is solve these for t, both of these. So if I solve them for t, I'm going to divide both sides by 270. And now I've got a number here that t equals. So t is going to equal, and if you divide that, 810 divided by 270, you get 3. So t equals 3 on this side. And on this side, I'm going to divide both sides by r. So t is going to equal 810 over r. So now let's address this idea of the time. All right, this was the plane this is the small plane over here, and this is the plane this is the Boeing. All right, and when we're concerned about the time now, I'm thinking that it took the, how can I say, I could subtract, because the Boeing left an hour and a half later. So if I subtract 3/2, which is 1.5 hours, in this case, I'm going to use fractions, 3.2. And then I could say, well, I could plug in, or I can just use it like this. If I solve for t again, I could just add the 3/2 to both sides. So it would look like 810 over r, and then I'm going to add 3/2 to both sides, plus 3 over 2 equals t. All right, I hope that makes sense to you. This is the hardest and stickiest part about these, because there's not just one way of looking at this. You could look at it a different way. Okay, I could have added the t over here if I wanted. But nevertheless, I'm going to stick to what I'm doing here. So t equals 3 over here, and t equals 810 over r plus the 3/2. And now what I want to do is get these equal to each other. So that means I want to come over here. I'm going to erase this t, and I'm going to put it in place. In its place, I'm going to put 810 over r plus the 3 over 2. Okay, and let's see how this works out for us. See, I'm going to put this over 1. I want to get my denominators to be the same now. All right, so this 2 I'm going to multiply by r, top and bottom. The r here I'm going to multiply top and bottom by 2. And the 1 I'm going to multiply by 2r, top and bottom. 2r times 1. All right, and let's see what we come up with. Our denominators are the same, so I'm going to have 6r. That equals, what is that, 1620 plus 3r. That's an r. All right. How about we subtract 3r, both sides. And I'm going to have 3r equals 1620. Divide both sides by 3. And r is going to equal, well, what does that come to? 3 into 1620. You can do it on your calculator, of course. I've got 5 there. 15, subtract. 1, 2. 3 into 12 is 4. 4 times 3 is 12, so I get a 0 there. So it's 540. So r equals 540. And answering the question, of course, what was the average speed of the 747? 540 miles per hour. Train A has a speed 15 miles per hour greater than that of train B. If train A travels 150 miles in the same time train B travels 120 miles, what are the speeds of the two trains? Okay, well, this is a nicer one. All right, because I got the two trains. Let's call this one train A. And what about train A? If we're talking distance equals rate times time. So train A has a speed 15 miles per hour greater than that of train B. All right, so train A is going to be going R plus 15. That's their rate. If train A travels 150 miles in the same time train B hold on. Excuse me. I've had this terrible cold. I can't get rid of it. I hope it's not, you know what? Okay. I don't think so. I think I'm okay. Equals, so train A traveled 150 miles. So I'll put that here for the distance. And it equals the rate times the time. So there's my first sentence. If train A travels 150 miles in the same time, those are the key words, that tells us we're going to solve for t in both of our equations. Because train B now over here, that is going what? 120. Distance equals rate times time. So the distance here is 120 miles equals just the rate r. We don't know any other rate in times time. Train A is the one that went 15 miles per hour faster than that of train B. So that determines that. All right, so let's solve both of these for t now. So here I'm going to divide by r plus 15. Okay, r plus 15's cancel, so t equals this 150 divided by r plus 15. And over here, I'm going to divide both sides by r. And t is going to equal this 120 divided by r. So I got a t equals over here and a t equals over here. So I'm going to take this and substitute it for the t over here. So that'll give me 120 over R that equals 150 over R plus 15. And here's our problem. You can cross multiply here if you want, or you can get the denominators to be the same. So maybe I'll just remain consistent here and get our denominators to be the same. So I'm going to multiply this side by R plus 15, top and bottom. And the R plus 15 over here, I'm going to multiply top and bottom just by R. Okay, denominators are the same now, so I can concentrate on my numerators. So if I use the distributive property here, I'm going to have 120 R plus, what's 15 times 1200? I'll do that real quick. 15 times 1200, no, 120. And that's going to give me 1800. And that equals 150 times R, which is 150 R. So it looks like I got a little something on the easier side here coming, because I'm going to subtract 120 R, both sides, and that'll give me 30 R that equals 1800. Dividing by 30, R equals, zeros cancel, 60 miles per hour. And then if they wanted to know I think they do, what are the speeds of both the trains, right? Let's see, what are the speeds of the two trains? Well, I can come over here and let's see where I had it originally, the R plus 15. So if R equals 60, so one answer is R equals 60 for one of the trains. The other is that R equals 60 plus 15. And that's what the R is for, that we're replacing here with 60. That's the reason why. So the second train is going to be 75. All right, and that's it for that problem. A bakery delivery truck leaves the bakery at 5 a.m. each morning on its 140-mile route. One day the driver gets a late start and does not leave the bakery until 5:30 a.m. To finish her route on time, the driver drives 5 miles per hour faster than usual. At what speed does she usually drive? All right, to make up for that. All right, so let's see, what do we got here? Another distance. Distance equals rate times time, and distance equals rate times time. All right, so the first one we're going to go when they leave. We're going to compare the two, and we have the delivery truck leaves the bakery at 5 a.m. each morning. So this or she goes 140 miles, and at a rate which isn't given, times the time. Okay, that's all we have for that one, and that's if she's on time. One day the driver gets a late start and does not leave the bakery until 5:30 a.m. To finish her route on time, the driver drives 5 miles per hour faster than usual. At what speed does she usually drive? All right, so now this driver here is going to have 140, same person of course, equals the rate, and she's going to go 5 miles per hour faster than usual. So the rate is going to be R plus 5. And then times the time. Okay, and I'm gonna venture to say that the time now, well, let's get our equations equal to t first. So that means I'm gonna divide this by r, both sides of course. These cancel, and I'm gonna have t equals 140 over r. Okay, and then on this side I'm going to divide both sides by r plus 5. And these cancel, and now over here I'm going to have t equals 140 divided by r plus 5. Okay, now next you can look at this two different ways. All right, and that would mean that, let's see, from 5 to 5:30, we'll say that's a half an hour, okay? And we want to use 1/2 because these numbers here, the time is always based on hours. So if she's a half an hour late, we can use 1/2. So I'm going to pick on this side here. And if she's making up the time by driving 5 miles per hour faster, then I got to say that the time is, I'm going to subtract 1/2. That's the 1/2 hour that I want to account for. All right, so here's what I've got thus far, and I did this to try to emphasize what the 1/2 hour significance is. Another way of doing it is I could add a half an hour to this side of the normal side. But this more represents it the same way. It's how you see it. Like, both ways can be correct. Okay, so now I want to solve for t again here. So this just means I'm going to have 140 over r plus 5. And then that's going to be plus 1/2. Okay, and now I'm going to take, and remember this equals t now, so I'm going to take, if t equals 140 over r and t equals 140 over r plus 5 plus 1/2, well, I'm going to substitute this t here with this 140 over r. Or you could go the other way, but I don't want to do all that writing. So I'm going to erase this t and substitute it with 140 over r. And now this is my equation. And I want to solve for r. All right, so if we get our denominators to be the same, well, it looks like I'm going to multiply top and bottom here by 2 times r, which is 2r. I'm going to multiply the 2 by r times r plus 5. R times r plus 5. And then this r over here, I'm going to multiply by 2 times r plus 5. And I'll put it as 2 times r plus 5. All right, I know my denominators are the same. That's why we do that. And let's figure out our numerator. 2r times 140 is 280r plus, well, this is times 1, so it's going to be r squared plus 5r. And that's going to equal, wow, what do we got here? 140 times 2 is 280. 280 times r is 280r plus 5 times 140. 5 times 0 is 0. 5 times 4 is 20. Put down the 0, carry the 2. 5 times 1, oh no, that was 280. Wait a minute. I've got 180 times 2 is 280 times r is 280r. 280 times 5. 280. I could have doubled it. 280 times 5. 0, 0, carry the 4. 1400. Okay, made it. 1400. That's what 140 times 2 times 5 is. All right, so I got a quadratic I got to get it equal to 0. So I'm going to subtract 280 from 280R from both sides, minus 280R. And then what the heck? I'm going to subtract 1400 at the same time. Subtract 1400. I'll just throw it over here. Okay, so I know this is going to be 0, and that's going to equal, over here, I'm going to have R squared plus 5R. And 280 minus 280 is 0, and then the negative 1400 comes here. And I guess I could add that. Of course, it's in the wrong order, but we can fix that up. A little bit of room here. So I'll bring it down over here. What have I got? R squared plus 5R minus 1400 equals 0. And now I've got to factor that R squared plus 5R minus 14. Okay, so, forgot what that was now. I'm going to set up my parentheses. I got an R here and an R here, plus, minus. So what are two factors of 1400 that subtract to give you a positive 5? How about 40 and 35? So, remember, it's equal to 0, so we got to make this a true statement. So R has to equal negative 40, but we don't want that because the rate cannot be a negative number, so we discount that. Or my other answer is R equals 35. And that's the rate that we're looking for. It's positive 35. Okay, and that's the answer for that one. Now I believe I have one more, and that has to do with our work problem. Let me find that. Okay, and here it is. A water tank can be filled by an inlet pipe in 8 hours. It takes twice that long for the outlet pipe to empty the tank. How long will it take to fill the tank if both pipes are open? All right, so what do we got here? Let's talk about our setup here. As in the examples I gave in the other video lecture, you know, it's going to be 1 over something plus or minus 1 over another something. That's going to equal 1 over x. Okay. So now what is it? A water tank can be filled by an inlet pipe in 8 hours. So this is going to be 1 over 8, because this 1 represents 1 hour of the job. How long? What does it accomplish in 1 hour? It accomplishes 1/8 of the job. It takes twice that long for the outlet pipe to empty the tank. All right, so we got water coming in and water going out, so that's subtracting. I'm going to subtract that. So I don't want the plus sign. I want it to be subtracting away the water going out. And if it takes twice that long, they're talking about 2 times 8. And 2 times 8 is going to give you the 16 here. And now I have to solve for x here. And that'll give me the number of hours it'll take for to fill the tank if both pipes are open. All right, so this looks pretty nice. So I'm going to make this the left side here. The 8, I'm going to multiply that by 2x top and bottom. The 16, I'm just going to multiply by x top and bottom. Make that an x since it's a 1 there. And the x, I'm going to multiply by 16. That way all 3 of the denominators have a 16x in it. And then my equation becomes 2x times 1 is 2x minus x, which was before x times 1. And that's going to equal 16. So 2x minus 1x is x equals 16. And that would be our solution. Doesn't seem right, but I'm going to check that real quick. Okay, I'm going to check that answer. So we are saying that 1/8 minus 1/16, 1 over 16 equals what? 16? X equals 16? 1 over 16. Well, of course it does. Well, 2/16, yeah, that's going to be it. If I added 1 over 16 to both sides, 1 over 16, then that would say that 1 over 8 equals 1 over 16 plus 1 over 16, where the denominators are already the same, and I add the numerators, it's 2. 2 over 16 equals 1 over 8. So have no fear, it just didn't look right to me at first. Okay, that's it. I hope these help. I really do. And good luck. And it should help you on the homework problems anyway. All right. Have a good day. Goodbye.